This is a key to worksheet 29 or topic 29. And in number one, you're asked to determine whether the graph represents y as a function of x. And then you write the word either function if it is a function, or if it's not a function, you just write the word not a function. To look at or to determine the answer to this, remember the definition of a function. So the definition of function, for each x coordinate, there's exactly one y value or one y coordinate attached with it. So for each element in the domain or for each element in the input, there's exactly one element of the output that's associated with it. So if you look at number one, if you look at, let's say, this point right here, for this x coordinate, there's only one y value. For x equal 2 right here, for x equal 2, there's only one y value associated with it, and that's the y value 2. And over here, let's say for x equal -2, here's the point, there's only one y value associated with it, and that's -2. So for each x coordinate here on this graph, for each x coordinate, there's only one y value associated with it. And so that's the idea, that vertical line test that you can use to determine if a graph represents a function. So if the vertical line intersects the graph everywhere just once, you got to look everywhere, then that graph represents a function. So the answer to this one is yes, this relation represents a function. So this is a function. And the same idea here. So if you look, let's say at when x is 0, and so there's the point associated with it. There's only one y value, and that y value is 1. Over here, when x is 1, this y value is approximately, let's say, 0.5 right here. And so that we can use the idea of that vertical line test to help us determine if a graph represents a function. So no matter where you draw this vertical line, it intersects the graph just once, meaning this: for each x coordinate, there's only one y value associated with it. All right, so this is a function. When you look at this one, this relation right here, this graph, let's say we look at when x is 4. See, x is 4 right here. So there are 2 points. There's this point and there's this point. Notice that when x is 4, when x is 4 right here, the y value is, and let's just go by, okay, this is 3 right here, so the y value is 2. When x is 4 over here, I didn't mean 4, yeah, x is 4, my y value is, in this case, is -2. So notice when x is 4, there are 2 different y values. That is not a function. Remember, a function says for each x coordinate, there's only one y value associated with it. In this case, there's 2 distinct ones. So if you look at that vertical line test, the vertical line test, no matter where you intersect it in this area here, it intersects the graph twice, meaning that for each of those x coordinates, there are going to be 2 different y coordinates. So that's not a function. Now you may say, what about here? Well, that's true. When x is in this case, x is 0. When x is 0, my y value is 0. There's only one y value here, but it's got to be this way everywhere. And so except for this one little time right here, everywhere else, it fails the vertical line test. So this is not a function. All right, number 2. So number 2, you're given these relations in terms of tables, output tables, input tables, or mappings, however you want to call that. So this input's that same idea as the domain. So if you look at this let's call this x. If you look at this x value, there are 2 different y values. There's a 6 and a -6. So right away, you'd even have to look at the rest of this, because this automatically fails the definition of what a function is. So this is not a function. So this is not a function. Now, when we go here, so some students get confused with this because they see just this one output right here, this one y value, this one element of the range. And so you've got to remember the definition of a function. For each x coordinate, there's exactly one y coordinate associated with it. So if you use that definition, when x is 1, there's only one y value, it's 4. When x is 2, there's only one y value, it is 4. When x is 3, there's only one y value, it is 4. When x is 4, there's only one y value, it is 4. So even though all these x coordinates, all these inputs have just one y value, have that same y value, that still satisfies the definition of a function. So that's a function. All right, now when we look at this one, so when x is 0, what's my y value? My y value is 6. So we're good so far. When x is 2, what's my y value? It's 6. It's okay for different x coordinates or x values to have the same y coordinate. You just can't have an x coordinate having different y values. And so when x is 4, there's only one y value, so this is a function as well. All right, so that's letter C. So letter D, so this time we use the word domain range instead of input output. So remember the different ways of indicating relations. Here, it's kind of the same idea as in letter A in it. So when x is 3, you have more than one distinct y value associated with it. So that's not a function. All right, you're given this xy table. When x is 1, my y value is 2. When x is 2, my y value is 4. So far, for each of those x coordinates, there is just one distinct y value. When so you only see x listed once here, so that's 2. X listed once here for x equal 2, so that's 4. When x is 3, I only see one x equal 3, and that's 6. So that's a function. And F is just like the above right here. So notice if I use that vertical line test, it fails the vertical line test. Now, for this right here, it only when I use the vertical line test for this x value, if it's let's say 10, there's only one y value. In this case, it looks like it's 4. For this x value here, when x is 0, there's only one y value, which is 4. But that doesn't matter. You got to find at least one place where it fails a vertical line test. If it fails a vertical line test, then it's not a function. So circles, or the relation of circles, are not functions, because you can obviously see it's going to fail the vertical line test in an infinite number of places. All right, so that was F. So when we get to the next problem, you'll notice that you're given a set of ordered pairs. So a finite set of ordered pairs. And it says determine whether the relation is a function, right? Yes or no. And then you want to state the domain and range of each relation. So what some students do is to help them, they want to write it in terms of this input-output table, sometimes written like this. So what that looks like is this. So let's look at letter A. So here is my, and I'll just call this X, or domain or range, whatever you want to call these, and this will be Y. So X, or domain, or input, Y, or you can write the word range, or you can write the word output. So what I would do is this to help you to understand or to use a definition of a function. When X is 2, notice my Y value is 3. So you have an arrow pointing away from 2. So it's negative 3 right here. So far it looks fine. When X is 2, I only have one Y value. The next one, when X is 3, I only have one Y value. It is 4. When X is negative 1, I only have one Y value. It is 2. Now, as you go through this process, make sure that you only list these numbers once. Okay, so if there's another 2, don't put it right here. You already have it listed. All right, so it's very important you do that. Otherwise, you're you're going to miss that opportunity to truly understand the definition of a function. So this is a function. So we're going to use the word yes since that's what the direction said. And the domain, now as you write the domain, in this case it was only listed once each case for your domain and range or your x and y, but only listed once. If it repeats, only listed once. Okay? And then you want to write these as a set. So you're going to use this brace. Don't put parentheses. All right, you have to write this as a set. A set, when you indicate a set, you don't use parentheses. You use this symbol right here, this brace. So, and it doesn't matter in the order in which you write this, since there's not that many ordered pairs. I'm going to try and put this in numerical order. So we have -1, we have 2 and 3. So that's my domain. So remember, your domain is a set of x coordinates. Your domain is a set of x coordinates. Your range is a set of y coordinates. And let's go ahead and put that in numerical order. And again, it does not matter. You have -3, 2, and 4. All right. Okay, let's look at letter B. So again, let's do that idea of that mapping. So we have x, we have y. And when x is -3, so I'm looking at these ordered pairs, and there's 1, 2, 3, 4 ordered pairs. When x is 3, my y value is 4. When x is -2, my y value is 4. And I already have a 4 listed, so just you don't write it again. All right? You want to make sure it looks like these, so you can help yourself understand whether it's a function or not using the definition. When x is -1, my y value is -1. So far, it looks like this is a function, right? So for each x coordinate, there's only one y value associated with it. When x is 3, my y value is -1. So we're good. For each x coordinate, there's only one y value. It doesn't matter that these two share the same y value. It still passes the definition of a function. For each x coordinate, when x is -3, there's only one y value. When x is -2, there's only one y value. When x is -1, there's only one y value. When x is 3, there's only one y value. So that's a function. And so we're going to list these. I'm going to put these in numerical order, although it didn't matter. Now remember, like we mentioned earlier, only list the elements of the set once. So you see how -4 repeated twice here, and the -1 repeated twice, only listed once. Don't put 4 things here. There's only 2 distinct elements, so list only 2 things. And make sure you use braces. So my domain would be -3, -2, -1, 3. And my range is a set of y coordinates, and there's only 2 distinct ones, so -1 and 4. Okay? All right, letter C. So in letter C, we have, again, it helps to do this, to use that idea of that mapping right here. When x is 2, my y value is 2. When x is -1, my y value is 5. So far it looks good. For this x coordinate, there's only one y coordinate. For this x coordinate, there's only one y coordinate. When x is 5, I get 6. All right, so far it looks like the definition of a function. When x is 2, okay, now we already have it listed right here. Don't list it again. When x is 2, my y value is -4. All right, so now we see that this is not a function because when x is 2, there are 2 different y coordinates. So this is not a function because when, I'm going to go ahead and write that here, when x equals 2, there are 2 different y values. And remember, the definition of a function says for each x coordinate, there's got to be just one y value, not more than one, just one. Okay, so this is still a relation. You can still talk about the domain of that relation. So the domain here, there are 3 elements. Okay, remember the 2's repeat, but only listed once. So we have -1, 2, and 5. Over here, the range, we have -4, 2, 5, and 6. Okay? All right, and remember, make sure it looks like a brace. All right, and then finally, letter D. So let's do that same idea. So we have X, we have Y, or you could put input, output, does not matter. When X is 0, my Y value is 5. For this X coordinate, looks like there's only one, right? When X is -2, my Y value is 5. Now remember, 5 is only listed once already, so don't list it again. When X is 1, my Y value is 5. When X is 4, my Y value is 5. When X is 5, my Y value is 5. So notice for each X value, for each input, there's only one output. It doesn't matter that all my elements in the domain share the same output. That doesn't matter. It still satisfies the definition of a function. For each X coordinate, there's only one Y value. All right, so that's a function. And so when you do the domain, nothing repeated here, no element of the domain repeated. So let's just put this, and that's a 5 right here. Let's put this in order. You don't have to. So you have -2, 0, 1, 4, and 5. Now the range is only one element, right? Although you see 1, 2, 3, 4, 5, all you see five ordered pairs, there's only one distinct element for the range, and that is just 5. All right, so that is the key to worksheet topic 29, worksheet 1.